She texting all of her friends, like look at the whip that we in. We coolin' for the weekend, drop the top and then we out. We do this every season. Sunshades on a sunny day, doing 80 and we switching lanes. Just keep it cool and chillin' with the bae. Don't call my phone, I hear what you say, or what you say. We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know how what we catch you.
Hey guys, what's up? It's your boy Trix. Today we're going to be doing Akka Cluster with Java. It's a small-ish tutorial today, so I was thinking I'll just go over the roadmap again. Because, interestingly, this roadmap isn't like as fleshed out as I thought it was. So, if I go to the GitHub one that I found before, let me just click on this. Sorry, I still got a cough. So, if I do open image in new tab, this should just give me the raw. Okay, so Java covered Gradle, covered University, has helped me cover these ones. Same with these ones. Okay, so CLI, J Commander, Airline, haven't touched either of them, and that isn't here. So there are just certain things that I am realizing that isn't in this one. If I just reset this, what is it? Oh, that's funky. Yeah, 400, fine. Okay, so J Commander Airline. Then go down a bit, we got web frameworks, Play, Spark, Chizzy, and Nano HTTP. Now, what you guys might notice here is Spring isn't there, but it's here. I mean, Spring isn't on this one, but it's on the other one. So, no idea which one to follow. Oh wait, Spring is there. I'm just blind, sorry. Okay, then we go down a bit. ORMs, Hibernate and eBean. We go over to here. Web frameworks, Build Tools, ORM, JPA, Spring, Hibernate, eBean. Then databases, DynamoDB, Azure, Postgres. Now over here, ORMs, JDBC, then logging frameworks. Doesn't actually talk about databases, right? But I'm guessing in the backend one, got it here. So then you've got search engines, then caching. Then logging frameworks, then RTC. It's just very weird. So, with that being said, I am going to stick with roadmaps.sh because, purely speaking, I do not think it is a bad... I don't think it's bad, right? certain things could be better. Like on the Java one, it does link you to it, and it does give you like Java crash course. I would have liked to link the Java MOOC by Helsinki here, but fair enough. Then it gets you into Git, and then if you click on this, click on the Java dedicated roadmap, you can go through this, then you can hop back to backend, and then continue on your journey. That's pretty much what I'm going to do. I'm going to go through Java, and then I'm going to go through backend, and each time there is a blue one, it's a new roadmap that you should just go through, right? So this is one roadmap that you can go through, which I'm going to do. Then you'll go back to visit them, then you'll go back to this one, then you'll do API security best practices, going through this, so you'll be a more well-rounded developer, right? And then once you've done backend, once you complete all the backend, you'll go to DevOps, you'll do this stuff, and then keep learning, right? So I am going to keep doing this, just it's a bit awkward because then because I'm primarily going to be focusing on Java. In the backend one, it does recommend other languages, right? Like there's one for Go. There is one for Rust. There's one for JavaScript, Python, Ruby, PHP, C#. C# and Java are basically the same anyway. So this learning path, it's recommending the Microsoft ones, but they're basically the same. Just C# has access to like LinQ and some cool stuff. That Java you'll have to like use third-party packages for. Well, C# they'll just have them built in, but just kind of weird. Anyway, today on the roadmap, we are currently at play, right? So we're doing the play framework ones. If I mark what I've done as done, these are just fundamentals. Then if we go into these are all just fundamental. I've done Gradle, I've done Maven, haven't done Ant because no one really uses Ant from what I know. And I've done Spring and Spring Boot. I'm currently doing Play. Right? And then next we're going to be doing ORMs, and then logging framework, then, ORMs, then JDBC, no, ORMs, then logging frameworks, then JDBC. Because it leads on nicely. But yeah. I wish this would persist, because I know I'm pretty sure I've done this before where I've ticked off the ones that I've done, but I know it does. If I close the browser and open it again, it won't persist. But we're getting there slowly and steadily. We've got 1, 2, 3, 4, 5, 6, 7 tutorials on Play to get through, and then we'll be moving on to Spark. So that's going to be fun. And then after we've done Spark, we're going to move on to JPA. And I don't even think there is really there is a tutorial, but if I go to Ant's website, is there a tutorial here? Nah, it's just documentation. There's books. The in-action books I do recommend, just because it has you get hands-on in actually trying to do something with the thing you're trying to learn. I wish there were I wish there were just tutorials somewhere. Anyway. Yeah, because I'm pretty sure if you go to Maven, yeah, there's a getting started with Maven, and in Gradle, there's a Gradle tutorial. Not the YouTube one, I don't want that playing. Yeah, Gradle has some tutorials and stuff that are pretty good. This is, yeah, I'm guessing you could recommend Springs one as well. So Apache made Ant and they made Maven, so what was the point of making both? Just use one. Just shell one. Anyway, this tutorial contains 3 samples illustrating different Akka cluster features. Subscribe to cluster membership events, sending them messages to actors running on nodes in the cluster where routers. Open application.conf to enable sorry guys. Do I have oh. Oh. There we are. If I CD into programming, sorry my voice is getting worse. CD into do they link to the source code that I can just download this from? No. Okay. So I'd have to go into here, right, which is just this. Then does it link to its own? Nah. I'll just clone Akka samples. Oh yeah. Sorry guys. And then cd into Akka sample cluster. Okay, cool. Now if we go into application.conf, that's going to be in SLC main Java, no, resources. There we are. To enable cluster capabilities in your Akka project, you should at minimum add the remote settings and cluster as the Akka actor provider. The Akka cluster seed nodes should normally also be added to your application.conf file. The seed node are configured contact points which newly started nodes will try to with nodes to join the cluster. Note that if you are going to start nodes on different machines, you need to specify the IP addresses or the host names of the machines in application.conf instead of 127.0.0.1. Open simple cluster app.java. simple app. Yep. Small program together with its configuration starts an actor system with a cluster enabled. It joins as the cluster starts an actor that logs some membership events. Take a look at the simple cluster listener. You can read more about the cluster concepts in the documentation. To run this sample, first make sure everything is compiled using mvn compile. Let me just... Does it only support Maven? Yeah, bollocks. Oh yeah. You have to compile before you build, sorry. Exec java -d exec.main class sample cluster simple app. That should work now. It starts 3 active systems cluster members in the same JVM process. It can be more interesting to run them in separate processes. Stop the application and open 3 terminal windows. Oh god. This is gonna look a bit funky because I'm gonna have multiple windows in the same folder. But you know what? We'll see how it goes. So if we do another window and another one. Cool. I just want to chuck this one up here. No, I'll chuck this one over here. So if I cd into akka -sample -cluster java, I'll do the same thing here. I tried to reverse search it and I couldn't find it. Cool. Okay, in the first terminal window, start the first seed node with the following command. There we are. Corresponds to the pull of the first seed node elements in the configuration. In the log output, you see the cluster node has been started with the change. Oh yeah, I need to press enter, don't I? With change status to up. In the second terminal window, start the second node with the following command. There we are, that's up now. 25252 corresponds to the port of the second seed node elements in the configuration. In the log output, you see that the cluster node has been started and joins the other seed node and becomes a member of the cluster. It starts change to up. 2525 is up, 2521 is up, and 252 is up. Switch to the first terminal and seed node log out, then join. Start in third terminal with the following command. That's in this one. Now you don't need to specify the port number. 0 means that it will use a random available port. It joins one of the configured units. Look at the log output in different terminal windows. Start even more nodes in the same way if you like. Shut down one of the nodes by pressing Ctrl+C in one of the terminal windows. It will cause the node to do a graceful leave from the cluster, turning the other nodes in the cluster that is leaving. It will then be removed from the cluster, which you will see in the log output in the terminal. Okay, so this joined at 372.6.27 as its IP. So if I close this one, it should leave init join. That's 2522, 2525, output connection, upstream failed. Remote daemon shut down, processing with flushing remote transports, member is removed, removes after exiting, association to having UID has been stopped, all messages to this UID will be delivered to dead letters. Reason active system terminated. Nice. Look at the source code for the active again, it registers itself as the subscriber of certain clusters of events. It gets notified a stream of events leading up to the... I just want to switch those two this way. Thanks. After it receives events for changes that happen in the cluster, now we have seen how to subscribe to cluster membership events. You can read more about it in the documentation. Membership events show us the state of the cluster, but it does not help with accessing access on the other nodes. On other nodes, the clusters. On other nodes, the cluster. In the cluster. That's a documentation issue. Obviously, not that big an issue, obviously. To do what we need to use the receptionist. Oh, sorry guys. The receptionist is a service registry that will work both when in single JVM apps not using clusters and in clustered apps. Actor refs are registered to the receptionist using a service key. The service key is defined with the type of message that act is registered for it will accept and the string identifier. Let's take a look at an example that illustrates focus. How workers here only nodes with the role backend register themselves to the receptionist so that front-end nodes will know that what workers are available to perform their work. Note that a node could potentially have both roles since the node roles are set. The main provided only allows one role though. Sorry. The example application provides a service to transform text, and at a periodic interval, the front-end simulates an external request to process a text which it forwards to available workers if there are any. Since the discovery of workers in dynamic, both back-end and front-end nodes can be added to the cluster dynamically. The back-end worker that performs the transformation job is defined in worker.java. Cool. So if I VI again, and I feel a sneeze coming. It'll eventually update. Okay, there we are. And this one. There we are. When starting up, a worker registers itself to the receptionist so that it can be discovered through its service key on any node in the cluster. This is where it's registering it with the service key. Frontend that simulates user jobs as well as keeping track of available workers is defined in frontend.java. The actor subscribes to the receptionist with the worker's service key to receive updates when the available workers in the cluster changes. If a worker dies or its node is removed from the cluster, the receptionist will send out an updated listing so the front end does not need to watch the workers. To run the sample, make sure you have shut down any previous started sample, then type that. Okay, so if I just grab this. Transformation app starts 5 active systems, custom members in the same JVM process. It can be more interesting to run them in separate processes and stop the application from running the following command in the terminal. I don't want to open up 5 terminal windows because you won't be able to see all of them. But you can see the different dispatches for each one. And the IP addresses are different too. I mean, the port numbers are different too. And it has different worker numbers anyway. So I don't think I need to really show it. Like you can see the worker number as well, starting from 0 all the way to, I think, 4. There's a component built into Akka that performs the task of subscribing to the receptionist and keeping track of available access, significantly simplifying such interactions. Group router. Let's look into how we can use those in the next section. The group routers relies on the receptionist and will therefore route messages to services registered in any node of the cluster. Let's take a look at a few samples that make use of cluster-aware routers. Let's take a look at 2 different ways to distribute work across the cluster using routers. Note that the samples just show off various parts of the Akka cluster and does not provide a complete structure to build a resilient distributed application with. The distributed workers with Akka sample covers more of the problems you will have to solve to build a resilient distributed processing application. The example application provides a service to calculate statistics for text. When some text is sent to the service, it splits into words and delegates the task to count number of characters in each word to a separate worker, a routine of a router. The character count for each word is set back to an aggregator that calculates the average number of characters per word when all results have been collected. The worker that counts numbers of characters in each word is defined in stats worker. Whoops. Oh god. There we are. If I go, I think it's, no, this one, no, tab, there we are. Stats worker. Oh god. How do I close a buffer? Oh, you know what, I'm just gonna cheat a little bit. There. So, the service that receives text from users and splits up into words, delegates to a pool of workers and aggregates the result and defines as stats service. Note nothing cluster specific so far, just plain actors. Nodes in the cluster can be marked with roles to perform different tasks. In our case, we use compute as a role to designate cluster nodes that should do processing of word statistics. In stats sample.java, what's that? What's this? Stats app. Each compute node starts a stats service that distributes work over n local stats workers. The client nodes then message the stats service instances through a group router. The router finds services by subscribing to the cluster receptionist and the service key. Each worker is registered to the receptionist when started. With this design, a single compute node crashing will only lose the ongoing work in that node and have the other nodes keep on with their work, but there is no single place to ask for a list of current work in progress. I'm just checking that my door's closed. To run the sample, type this if it is not already started. Okay, so if I, sorry. I was slouching in my chair and my back was hurting. Stat sample starts 4 actors, four actor systems cluster members in the same JVM process. It can be more interesting to run them in separate processes. Okay. App 1 master. Each compute node starts n workers that register themselves on the receptionist. The stat service is run in a single instance in the cluster through a Akka Cluster singleton. The actual work is performed by workers on all compute nodes. The workers are reached through a group router used by the singleton. With this design, it would be possible to query singleton for current work. It knows all current requests in flight and could potentially make decisions based on knowing exactly what work is currently in progress. If the singleton node crashes, however, all ongoing work is lost through this since the state of the singleton is not persistent. When it started on a new node, the stat service will not know of any previous work. It also means that since all work has to go through the singleton, it could become a bottleneck. This needs a hyphen. Or just be altogether if it's supposed to be one word, because become is one word. If one of the other nodes crash, only the ongoing work sent to them is lost. However, since each ongoing request could be handled by multiple different workers on different nodes, a crash could cause problems to many requests. To run this, type this. App 1 starts 4 actors in the same Java process. It keeps saying that. Multi-JVM test kit, which allows for starting a cluster with multiple separate JVMs, is only available for Scala with Scala built to SPT. Such tests are included for completeness and can be found in SLC multi-JVM and then can be run with SPT multi-JVM test. Cool. Again, very short one, and it felt like more of a read than try doing this, try doing that, like with Spring, where Spring actually like had you changing stuff and saying, oh, okay, cool, this is what this does. If you change it to this is what happens and stuff like that. But I think the knowledge is there, and it teaches you a little bit about distributed networking. Not really. It does teach you about distributed nodes and like how it operates and how they do connect and like can gracefully disconnect, which depending on the software you're using might not be the case. There's a particular software I want to bring up in this, but I'm not going to. All I'm going to say is it begins with a H, but I think this is pretty good. Besides some like grammatical errors, and honestly, like lots of documentation does have grammatical errors, and it could just be that I can't read, which is a very fair possibility. I think it's pretty good. I would prefer if there was like a bit more of a. I'll use Spring as like the base standard because that's the only other like one that I've done so far. I would appreciate if this had a little bit more like of a tutorial kind of feel to it, because it feels more like, oh, here's what these things do, and it doesn't really go into like what the code's doing. It just tells you from like a high level point of view, oh, this is what this does and this is how it works, instead of, okay, cool, this is what this line does and why you're doing it, which I do appreciate from Spring. But Spring didn't cover clusters and like distributed load, whereas this could be using like clusters and distributed load on multiple nodes. So I do think some of the Spring tutorials are a lot better than this one, but this one is unique in terms that I have seen some tutorials like the ones that Spring were doing which are very generic. I haven't seen another like distributed node or distributed cluster tutorial before, so this might just be like a standard of how most of them are like. But I would appreciate if it was a bit more in depth in what is happening in the code, because even if I do open up the code and I can like suss out what's happening, like, to be fair, the code does not look that verbose, and it is quite concise, so you can just like make out what's happening and why it's doing it. But how do I explain this? I just feel like logically there should be a bit more explanation into why I'm doing it, instead of just, oh yes, this is what is happening in this file. I would appreciate if there was a bit more explanation, and like maybe if it was like, okay, cool, you start with the simple one and then it has you doing the small changes to get to move between them, like it did with Spring, just so you feel like just to feel like you're getting your hands on it, when really it's like, oh, you might just be like copy pasting, which is what the Spring one did, but at least you feel like you're getting your hands on it. With this one, you're not really getting your hands on it, you're just looking through the files, looking through the code, and sussing it out as you're looking at it, which everybody has their own preferences. I prefer the way that Spring done it, but I prefer more like tutorials that have you taking part in it, instead of just, oh, here's the code, here's what it does, and that's it. I prefer to like, okay, cool, you start from a base and you're incrementally improving it, so that you can see, okay, cool, here's where you started from, here's where you finished, these are the changes you've made, and like why you're making them. But that's purely down to personal preference. So anyway, I do think this was a pretty good tutorial, but I wish it was more hands-on. I'm hoping the next tutorial, because the two tutorials I've done so far haven't been like very edity, they've just been, okay, cool, here's what this does, here's what that does, and keep going. I'm hoping what this one looks like is a bit more in-depth, and it does have some code examples, so I'm hoping it will just be like, okay, cool, copy this, copy that, and telling you why it's doing it. So anyway, look forward to the gRPC tutorial next week. Anyway, like, subscribe, enjoy the rest of your day, and peace, guys.